All right, we're going to review and continue reviewing integration. We've already started a little bit of integration with reviewing the power rule and thinking about doing use substitution, that kind of things. But I want to do some more integration, just refreshing our memory on integration. So one of them I want to do is natural log. We know that when you take the derivative of natural log, it's the derivative of the function divided by the function itself. So when you integrate and reverse that, then that's the natural log of the absolute value of f of x, and then plus c. All right, so integrating, if you notice that the numerator is the derivative of the denominator because you have a rational function, then that is the antiderivative is natural log of the denominator in absolute value bars because you can't take the natural log of a negative number. Another one we want to talk about, review about, is e to the x. If you have e raised to the f of x, you know his derivative is himself times the derivative of the exponent. So if you're integrating that, dx, and you actually have e raised to some function multiplied by the derivative of the function, then that will be just e to the function plus c. If it's not that clear cut, you're going to do a u substitution, and your u substitution will be your exponent. Just like in natural log up here, if it's not clear cut that this is the derivative divided by the function, you'll do a u substitution and let your denominator be the function. And then the last one I want to do is a to the x. If you remember, the derivative of a function a to the x is a to the x, and then you have to multiply by the natural log of a. So if I'm going to do the antiderivative of a to the x, since the derivative was itself times natural log of a, the antiderivative is going to be itself divided by the natural log of a, and then plus c. So those three, I just wanted to review a little bit with you because other than the power rule and doing use substitution, everything reverses with use substitution. These are three of them that you need to know. Also, you need to know all the reverses of your trig functions, which you should know. If not, go back and review through those. So I'm just going to do one example of each kind. All right, let's say I'm going to integrate this problem here. That's 6x squared plus 2 divided by x squared plus x dx. So let's say I wanted to integrate that problem. I noticed that the derivative of the bottom is 2x plus 1. Oh, I had x cubed. Sorry. That makes a big difference. I want this to, that was supposed to be a 30. X cubed plus x. So if you notice, the derivative of the denominator is 3x squared plus 1. And notice your numerator, 3x squared plus 1. This is just double that. So notice my derivative of my denominator is in my numerator. So in that case, I'm going to do a u substitution. And let's change the color. Let's do green. We're going to do a u substitution and let our denominator be our u. So then remember, the next step is to do the du. So your du is the derivative of this. That'd be 3x squared plus 1. And then you multiply that quantity by dx, chain on dx. And then you solve for dx by dividing. So it'll be du divided by 3x squared plus 1. So now we're going to trade out. So we're going to trade out everything. So I'm going to keep, though, the 6x squared plus 2. And in the denominator, since that's what I said u was going to be, and we'll put a u under there. And we're going to trade out the dx, and we're going to put du divided by the 3x squared plus 1. Now, we talked about this earlier, that if we factor a 2 out of this, we're going to get 3x squared plus 1. So these will now cancel. So now when you do your antiderivative, I've taught you to do your coefficient first, so that's 2. And then do our function, this is gone. All right, do our function, which is going to be 1 over u, and then our bookend du. So when you do your antiderivative, and we'll switch back to blue, when you do your antiderivative, you keep your coefficient. The antiderivative of 1 over u is natural log of u because that's the derivative Derivative of u is 1 over the function itself. So that's ln of u plus c. So then my final answer would be just subbing in my u. All right. So then I would want to substitute in place of u, put back the x cubed plus x. So my final answer would be 2 natural log, and in place of u, put x cubed plus x, and then plus c. So that would be my final answer. So 2 times natural log of x cubed plus x plus c. Well, then again, if you remember, and what we could do is move this coefficient and put it on this quantity squared. We could do that if you wanted to do some extra work with that. All right. So that was one I wanted to do, just doing a natural log problem where you do the u substitution as your denominator. All righty. So the next one I would like to do is this one. So we've got x squared e to the x cubed. I'll try to copy it correctly this time. So x squared e raised to the x cubed dx. So I know this is the e one. And notice the derivative of x cubed is 3x squared. I got the x squared here. So we're going to do a u substitution. And we're going to let our u be our exponent, x cubed. So then your du is 3x squared dx. Solve for dx. So du divided by 3x squared. And now I'm going to trade out. So I'm going to keep the x squared. I'm going to write e to the u because that's what I said u was going to be, was x cubed. And in place of dx, I'm going to put du divided by 3x squared. Now notice your x squareds cancel, which is good because we want to be all in u's. So now we want the coefficient first, which is 1/3, then our function e to the u, and then our bookend du. So now I'm going to do the antiderivative. So my antiderivative, I keep my coefficient. The antiderivative of e to the u is e to the u, and then I put a plus c. So now I substitute my u back in. U was x cubed, so it's e to the x cubed plus c. So there's my answer, 1/3 e to the x cubed plus c. So when you got an e problem, you want to make your u substitution your exponent. All right, and then the last one I want to do is an example of the a to the x. All right, so let's say I had this one. We'll just do a pretty simple one because we hardly ever do anything really complicated with these. All right, so my antiderivative here, I keep my coefficient. My antiderivative of 2 to the x is going to be itself 2 to the x, and then I have to divide by ln of 2, and then add a plus c, and that's all there is to that. Now, if I had more of an exponent here for the instead of just x, I would do a u substitution, just like you do e to the x. You do the same thing. Do a u substitution and work that out. But this is usually the most complicated that our problems get. So that was all the ones I want to review. We've already reviewed power rule, reversing power rule. So everything pretty much, if you do u substitution, reverts back to a power rule. So just make sure you study your trig ones. And then in the other video, I'm going to do the inverse trig ones because I think we just need to look at those a little bit more intense than we have in the past. All right.